So we are again here to discuss the topic that is projection of solids. So today I'm going to discuss visual case third. So I'm already done with these two cases. So today I'm going to discuss this third case, that is axis inclined to one of the principal plane and parallel to other. And in that case I'm going to discuss visual axis inclined to HP and parallel to VP. So let's see the question. So this is my question. Pentagonal prism with side of base 30 mm and axis 60 mm long. Okay, so you understand that a pentagonal prism, this is my pentagonal prism, and side of base, any of this is your base, you know that this is your base, and side of your base is 30 mm and axis is 60 mm long. So if the axis length is given, it means the length of the solid is given. So the height or the length of the solid is given, which is 60 mm, is resting with an edge of its on base on HP. So you can see here that it rests on AB. This is the side of the base, ABCDE, and it rests on AB, this edge. Okay, such that the rectangular face containing that edge is inclined at 60 degree to HP. Very important constraint. So what the examiner wants to say that here, that on what edge it rests, AB, the rectangular face containing that particular edge, this face AB21, this rectangular face makes 60 degree angle with HP. Okay, so this is the proper imagination of my prism as per the question. Draw the projection of the prism when its axis is parallel to VP. So you can see it very clearly here. The axis line, this axis line is very much parallel to your VP. It doesn't make any angle with VP, although it makes an angle 60 itself with HP. So as per the question, the whole prism is inclined at 60 degree to HP. If your solid is inclined at 60 degree to HP, it means your axis is also inclined at 60 degree to your HP. It is very much clear from this imagination. So this B makes an angle with HP, but doesn't make any angle with VP according to this imagination. Okay, so this is imagination. I'm going to make this question, and you are going to make the projection of the prism, means you are going to make the front view and top view of this prism. Okay, so it is very much clear that it is not seenable or watchable from your front view and top view. The true shape of the solid is not watchable either from the top view, front view. So you have to assume something over here. So these type of question, when your axis is inclined with HP or VP, or your solid is inclined with HP or VP, you have to take the assumptions over here. So this is my assumption. So if it is this axis is inclined with HP, you have to make that axis perpendicular to that particular plane. Okay, so you can see here that this is my assumption. This imagination shows the assumption. So you can see here that I'll put my solid exactly on that face. So if you remember, this is AB edge on which my prism rests. Make my solid exactly perpendicular to your horizontal plane. Why with horizontal plane? Because solid is inclined with HP. So you have to make your solid perpendicular to HP. Okay, so if you make your solid perpendicular to HP, it automatically your axis also perpendicular to HP. So you can see here that this axis is exactly perpendicular to your HP. So now the angle with HP is 90 degree instead of 60 degree, whatever the question says. Okay, so this is my assumption. I start from here. So if you see that this is the first case in the projection of solids, if you remember that. Okay, I'll show you. You can see here that this is the case 1, when axis is perpendicular to one of the reference plane. Okay, so you can see here that now my axis is perpendicular to one of the reference plane. So I can start my question accordingly like that. So again, I'm taking the line. So there is no distance from VP and HP is given, so I can make my top view from anywhere. Why top view? Because from the top view I can see exactly my pentagon over here. Okay, so from the top view I can see my true shape of the solid. So that's why I'll have to make that top view first. So again, if you are going to make this pentagon, so you have to using polygon command. So this is my polygon command. Number of sides are 5. Enter. So edge is given. I'll take the edge. So I can start from this way. So this is, and the edge is 30. So this is done. So this is my top view of this, my assumption. So I'm taking the projections now towards reference line like this. Okay, so this is the way to take the projections from every corner of your edge. So I'll do not take projection from here, because I'll take a line from here, it overlaps from this point, so I'll take from only this point. Okay, so this is the reason I'm not taking from here. Okay, now you know that whenever you're going to make a cases of solids, in the projection of solids, you have to know the center of that, because in the center you have to make the axis line over here. Okay, so if you want to find out the center of this pentagon, one thing is, if it shows you geometric center if your O snap is on, but if your O snap is off, let it be off for some time, and you see that your O snap doesn't show the geometric center here. So how to find out the center of the pentagon? It is very easy. So you start making a line, start from here and go to the opposite midpoint. So you can see here, this is midpoint, just join this one. Okay, again take a line from any other corner and go to the center of that, this one. So wherever these two lines meet, that particular point becomes your center of the pentagon. So this is a way to find out the center of the pentagon only. Okay, now I'll take a line from here. So you can see here that this one. So this is my axis line basically. So I'll take upwards like this. Okay, I'll take first over here again and put line here. We have to show as per axis line, as per convention of lines. So make it axis line like this. Okay, so now I'm going to make the complete front view of this one. So you know that from the front view you have seen some edges over here. So I know that the distance or the height of the prism is 60 mm. So I'll take like this. I take a line from here. I'll go up to 60 only. Okay, and this way, and I take the O snap tracking over here, and this is done, and this one and this one. Okay, so in this way I'll make my front view. I'm left with only one edge, that is this one and this one. So in this way I'll complete my front view of this particular pentagonal prism. So now this is my assumption I'm going to make. So you can also join these things like this. Okay, so you can put join command to join this. Okay, so you can see that now it is one line only. So now what you're going to take is, now this is my assumption, because you know that in actual my prism is like this at a 60-degree angle with HP, but I make this axis as perpendicular to HP to see my top view. Okay, because from the top view I can see my true shape of the pentagon. So that's why this is an assumption only. Now in the second stage I'm going to make this question exactly as per the question. So what you are going to do is now here cut. So what you are going to do here, just put your this front view exactly at a 60-degree over here, because you know that the angle with HP is always seenable from the front view. Okay, whatever the front view is, it is always at an angle of 60-degree over here. So you have to put your this front view exactly at a 60-degree over here. So how to do that? Let's select it. Let's make a selection and make it copy. Okay, you can start from anywhere, but make sure your ortho mode is on in this way. Okay, so this is the way. So I'll put over here. Okay, I exactly copy my front view and put over here. Okay, and now know that it makes a 60-degree angle. So again I'll take select it, go to the rotation command and in the command line bar, it asks me specific base point, means from which point you are going to rotate your this particular object. So I'll take this one. So you can see that now my front view gets rotated, and I know that this angle is rotation as a 60 over here. So now I put my angle here, because in the command line bar it asked me about the rotation angle. So I put 30. Why 30? Because this angle is 30, this angle is 30, but this angle is 60 over here. Okay, this rectangular face is 60 over here, you know that. Okay, but this is your 30. This is 30 because rotation in anti-clockwise direction. So this basically rotate like this completely. So this is 60. So, and this is your 30. You know that according to your mathematics, because this is 90. This complete is 90. Okay, and this is, if this is 60 and this complete is 90, the remaining is 30 over here. Okay, so now this has been complete now. So I make a nomenclature over here first, so you can understand better way. So take a text command, and this is A. Okay, increase its text height. Okay, make it 6. This is done. Okay, so now I take this one. Okay, why? Because from the top view, this 1, 2, 3, 4, 5 face is first watchable from the top. This A, B, C, D, E face is watchable after that A 1, 2, 3, 4, 5. So whatever the face is visible to you in the projection of solids, that should be written outside, and whatever the face is not visible to you, it should be written inside of that particular shape. So this is A. In the same way, I'll make all the nomenclature. Okay, so this is a way to give the nomenclature of your top view. So I'm going to make a nomenclature in front view. I do not show you how to make this nomenclature, because I already show in the previous video how to do this nomenclature by just using copy command and move commands. So I just directly show you this nomenclature over here. So I'm going to make a nomenclature in the front view now. Okay, so this is the way to give the nomenclature of all the corners of this front view. So you know that I rotate this particular front view over here, so I have to make the nomenclature accordingly over here. So all these nomenclature should be put this side. So this is the way. Again, I copy this one, and put over here. So you know that this is 1, 2 point. Again, this one, copy, and you know that this is 5 dash E dash, and again 4, 1, and copy, put over here. One more thing is, you have to make like this. This is 1, basically this is 1 dash. Okay, so you have to make it subscript like this, and again put over here 1, and make it subscript over here. Okay, so this is the way to make the nomenclature. You know that 1 dash and 2 dash is already here. You cannot make two same nomenclatures in the front view. So you have to put extension of your nomenclature. So this is 1 dash, 2 1 dash. In the same way, all nomenclature have been done like this. Okay, so this is the way to give the nomenclature of all the corners of this particular pentagonal prism. Okay, now I'm going to make the top view with the help of this front view over here. So take a line and take the projections from every corners. Okay, so I'll take first from here, put down side like this one, take the projections of every corners. Again take this one, again take this one, come downwards. Also take the projection of this axis. Okay, so like this one. Okay, now again take a projection from this one. So for complete your top view, again take this one, again take this one, and this one. So you will take all the projections down. Now complete your face over here. Only one face I am taking presently. I am taking this 1 2 3 4 5, because I'll take, if I'll take projections of A, B, C, D also, it may be complex for some observers to see that which points will be visible to you. Okay, so you can see very clearly from the top view, when you see this this front view, from the top view, this complete face is visible to you. Okay, so I'll take a polyline over here, and you know that the points are here. This is one is coming here, and one from above side is here, so you know that this point is 1. Okay, in the same way the 2 is here, so 2 line is here and 2 line is coming here, so you know that this is 2. Okay, in the same way this is 3 line projection, and 3 is coming from top side from here, so this point is definitely 3. In the same way the 4 is here, wherever these both projections meet, that should be 4 point. And in the same way the 5 projection is coming downwards, and from the 5 this one is here, so this point is definitely 5. First locate your points over here so you can understand in better way. So I'll take the, like this, I'll make copy. I copy 1 and put 1 here, because you know that this is 1 itself, because the 1 is coming from this point and 1 is coming from this point. Wherever these two projections meet, that is definitely 1. Okay, in the same way I'll take 2, make it copy and put over here, this is 2. Okay, in the same way 3, this should be 3, because from the top you know that the 3 is coming from this one and 3 is coming from this one, so this, where these two projections meet, that should be definitely be 3. Okay, in the same way 4, copy it and put over here. The same way 5 and put over here. So this is the way to locate your points. I'm going to just make these points connected with the help of polyline now. This one, this one, this one, this one, this one, and last is again 1. Okay, so you can see that this is my one face of the pentagonal prism. Now I'm going to make another face, that is A, B, C, D, E. This is your A, so this one, so this is a projection line of from your AB edge. So you start with like this, A, this one, and put over here, this is A. Okay, so you can put anywhere like this one, so it should be A, like here. Okay, so in the same way take B and put over here, so you know that this is B. Take the projection from this also, this one, again take a projection also. Okay, now select C, so now make it copy and put over here, so you know that this should be C. Again copy your D and make it copy and put over here. Again E, make it copy and put over here. Okay, now you are going to make these points connected, so I'll take this one, this line, and start from C as well. This one E, this is A, this is B, and last one is C. Okay, so this is the another phase, that is A, B, C, D, E phase. Okay, in this A, B, C, D phase, when you see from the top view, it is very much clear that all lines are not visible to you. Means all the edges of this side, this base is not visible to you from the top. Only we have 4 edges which is visible to me, that is A, E, D, C, B. But on which this prism rests, AB, is not visible to me from the top view. So you have to make that particular AB line, this AB edge, should be hidden over here. Okay, so how to make this hidden? I'll take this one. First of all, I'll delete this one. So okay, then I select it. This AB line selected. Go to the bilayer, make it hidden over here. So you can see it goes hidden like this as per convention of lines. Okay, now I'm going to make the edges of these rectangular faces, because these rectangular faces also have edges, so you have to join both of your this pentagons with the help of rectangular faces. So take a line. So you know that this 3 to C, you can see that 3 to C, this edge is visible to me. Okay, so I'll make it visible. Again 4 to D, 4 to D is very much visible to me. So you can see that this 4 to D is very much visible. Again take a line, and 5 to E, this is also visible to me. Make these thick because these are visible. Go to the by block, make it like this. So these are also thick, so make selected and go to the block, make them thick as well as per convention of lines. So you know that if you see from the top view of this pentagonal prism, some edges are hidden over here and some edges are visible. The visible edges I already make over here. Now the rest edges are hidden over here. So you can see very clearly that this B to C, you can see here this B to C, when you see from the top, you cannot see this BC edge, and even AE edge is not visible from the top view. Okay, so you have to make these edges hidden. Okay, so you select these one and go to the layer and make them hidden. Okay, so you can see that these are hidden edges. Also two more edges, that is 2 to B and 1 to A. You can see it very clearly that 2 to B and 1 to A, that is also not visible from the top view. Okay, so you have to make these edges also hidden. So you have to make like this. Okay, I'll make these delete first. Okay, take a line, up to B, again take a line to 1 to A, this one, and now select these edges and make them hidden like this. So you can see that these are our hidden edges which will not be visible from the top view, and these are our visible edges which are very much visible from the top view. Okay, lines hidden or visible, it is very important in these cases. Okay, now I'm going to improve my nomenclature. You know that this is actually 1 1. Okay, so you know that this is 1 1, make it like this, subscript. Okay, the same way this is 2 1, make it subscript. Okay, it's not visible, so let's make it over here. Okay, so this is 2 1, this is again 3 1, make it 3 1, and so in the same way all nomenclature is done like this way. Okay, so in this way all the nomenclature should be like this. So this is your top view and this is your front view. Make your front view as well thick, because as per convention of lines. Okay, in the same way you also have to make this assumption thick. Remember it should be thick also. Okay, so like this I make all these things thick. Your projection lines should not be thick over here. So this is the way to make your pentagonal prism when it is inclined to HP. Okay, so always remember it, from which plane your axis or your solid is going to be inclined, make that particular solid axis always perpendicular to that plane. So if in this case your imagination, you can see very much clearly this axis is exactly at a 60 degree with horizontal plane. I'll take an assumption and I make my axis of this pentagon exactly perpendicular to your horizontal plane. So this is the way to start your question, and it will be solved in 2 stages only. Okay, one more thing, I'm resting only with the dimensions. You're going to take the dimension now. So take angular dimension. So you know that this one and this one should be 60, so it is 60 degree. And one more dimension, that is linear dimensions of the axis over here. So this is 60 mm, and again take a dimension, this one and this one, that is 30. Okay, all things have been done now. So if you like this video, please go to the like button in the description, and you still have any query, please comment in the comment section. Okay, thank you.